So we are going over reviewing chapter 2 today. The test is on Wednesday. Homework is due Wednesday. Test is on Wednesday. Make sure you show up with your homework ready to turn in order, stapled, filled out. Assignment sheet is filled out. Name is on it. Okay, everything's ready to go. Monday, there's no school. It's Veterans Day. So make sure that you don't show up because no one else will be here. We start on Wednesday next week with chapter 3/4. Want to make sure we're clear because I know I repeated. I have to repeat things that I shouldn't be repeating. I always have to. Things that I keep repeating over and over again, nobody pays attention. So, no, you cannot, even if you're not here, take the test later. No matter what the reason might be. Notes, doctor's notes, that doesn't, I don't need a doctor's note when you're absent. You email me, that's fine. You're sick. There's a doctor's note doesn't, I don't need the HIPAA laws coming after me because you're sharing medical information. I don't need those. There are no excused absences. It's just absent. And since the drop date has already come and gone, I only keep track of absences in terms of, do I drop you at 9 weeks or not? But now you can't drop and I can't drop. So this is how college works. That's why I built in and gone over on the first page. The syllabus says no makeup or retakes on quizzes. I dropped you 2 of those quiz scores. That way we don't have an issue. I can give the quizzes back as soon as I'm done grading them, but we don't have an issue with, I don't have to choose between you have a legitimate reason, you just making things up. I'm not put in that position. Otherwise, I'm going to have a list a mile long of people who want to take it later. And it's not fair to the people who have shown up and taken it on time. And then we got to figure out, when are you going to actually do that? And if that date comes and goes, well, I couldn't make it that day. Can we do it another day? Then we're just going round and round and round. I've been there. Okay. That's why drop 2 low quiz for it. Now we don't worry about it. You don't have to worry about trying to schedule it, and I don't have to worry about trying to chase you down. And it's fair to the ones that are here, because now I can give everything back, because if I hang on to it because I can't give it back, because if I give it back, then you know what the quiz was and blah, 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 blah. Okay, if there are people that still, and there's people that didn't take it, I couldn't give that quiz back to you because now the quiz is out there, and even though you have the quiz preps. So, same thing with tests. Well, can I, I'm this and whatever, and I can't have, and this, can I do it? And well, the answer is no for whoever, because once it's taken, then it's out there. And who's to say, and again, this is just going through all the scenarios that I've had to play out in order to be equitable and fair for everybody. The ones that show up, it's not fair to them for someone who gets to take it after everybody else who has access to what somebody might tell them was on it, which you have the review sheet. But it's still out there. But then I can't give back the test until everybody's taken it. And then we got to go through that whole, well, when are you going to take it if you're not? So we got to go through that. And then how many people don't show up on test day? Trust me, if we did makeups and retakes, there would maybe be a half of the room. The exam flu. Nobody feels good on exam day. So we don't, and that's why it's built into the syllabus. You miss a test or you do poorly on a test, the final counts twice and replaces your lowest test score, provided the final is higher than your lowest test score. So there's a safety net. So there is built in, the word is safety net, but there is a built-in catch-all. So we don't have to do those things like makeups and retakes. So those aren't for the people that do take care of business, that are on top of it. Now you may have incredibly legitimate reasons, but I cannot be that one that has to go yes and no to one and yes to one and no to another. It's just like I said on the first day with the syllabus. The answer is no. It has to be. And lately I've been getting lots of emails with, and it's like, I just want to say, please see the video of the very first page. Please look at the syllabus. I want to cut and paste the syllabus on there, but I don't want to be rude either. I really don't. I hate being a no person, but I want to be fair to everybody. And the way it's set up, I think it's fair to everybody. And that may be somebody going, well, that's not fair. Sorry. You're never going to make everybody happy either. Welcome to the human race. But back to the text. This is what you have to know. And please remember, when you email me through regular good old email, not through replying through Canvas. That way replies don't get lost. So I can't separate those in Canvas. I can get them separated out into other folders. On the review, number 1, you got one of them. Number 2, you got one of those. Number 3, you got one of them. Number 4, you got one of those. So you have one problem where it's addition or subtraction. Okay. You have one problem where you have to multiply, one problem where you have to square something out, and one problem where you have to rationalize a complex rational number. So just like the quiz, the only difference is number 4 on the review sheet was a bonus question on the quiz. Numbers 5 through 7. Solve by factoring. You have 1. Solve by factoring. Very straightforward. Very straightforward. Okay. Numbers 8 through 10. You have 1 mandatory complete the square. Your work has to show that you're completing the square. Okay, very straightforward. Then 11 through 13, 1 quadratic formula. So the directions are very explicit. You have to use those methods, factoring, completing the square, quadratic formula, to solve the equation in that method. Any other method with any other word gets you 0 points, even if the answer is correct. The work has to match the question and the direction, even if the answers are right. Okay. Then 14 through 20. You basically have 1 of each kind. Literally. Not necessarily in that order, but you'll have 1 like 14, 1 like 15, 1 like 16, all the way through 20. for a total of 14 problems. At 10 points apiece. So it's 140 points. There are 6 bonus at 5 points each. So that's 30 points. So the max would be 170 out of 140. But if you look at the bonus examples that I put on there, you definitely will have one like 1 and 2. One where you have to solve them by completing the square. One you'll have to do by the quadratic formula. So go back to the examples numbers 8 through 13, and then you're looking at ones that actually, like number 10, completing the square, but it's 5x squared. So you have to divide everything by 5 before you can do the next step. You can only do completing the square if it's 1 times x squared. So the bonus is where you have that fraction piece. Number 12 and 13. Okay. Quadratic formula, if you have fractions in it, please don't put fractions into the quadratic formula. You're just making a mess for yourself. It never works out nicely. Undo the fractions. First step, rewrite it in standard form. Undo the fractions. Make them nice numbers for the quadratic formula. Make sure equal 0. And then there's one like a decimal. Number 3, there's something that you have something to do with power like that, where you're doing multiple multiplications. I like number 5 a lot. And then number 6 and 7. Now there's 7 bonus questions, but only 6 on the test, or 7 on the review sheet, but 6 on the test. It's either going to be something like number 6 or number 7. Let's just be straight up. It'll be number 6. Why mess with it? It's going to be something like number 6. Because that's the one we did an example of that last week on the homework. See how you have to twist my arm? You know exactly what to expect. No surprises. But you have to be able to show the appropriate work that gets there. There were some quizzes where there was only the correct answer and no work in between. You're not going to get full credit at all. You're not going to get much credit at all. Okay. Work has to justify your answer. You should know that by now. So, now on you. Tell me what you want to see. Is it from the review? Is it from homework? Is it from the quiz? 18 on the review. 18 on the review. You tell me exactly which question. I will be glad to do it. Number 5.
Number 11.
Slow down. There was never a court order cook. I could never. How they yell things back and forth from the kitchen to the front, I have no idea. Okay, so I heard 18, and then 5, and then what's the next one?
11.
11. So stop there. Okay. Six minus 1 over 10. Squared. Number 6 says solve using any algebraic method to appropriate work. Well, first of all, it's not even a quadratic. We have fractions, undo the fractions. Undo the fractions, we need to multiply every term by the least common denominator. Well, first of all, I would want to undo an x, so I would multiply by an x, but multiplying by an x is not going to undo an x squared. What's going to take to undo x squared? An x squared. So if I multiply 1 over x times an x squared, will an x squared undo x to the first? Does x go into x squared? Yeah. So x squared is your least common denominator. And some of you are still struggling with finding the least common denominator. Some of you still struggling with that. The least common denominator is x squared. So every term gets multiplied by an x squared. Every term, so we can undo the fractions. So that's now 6x squared minus x goes into x squared, leaving x to the first, equals 1. No more fractions. And now we actually have a quadratic. Before it wasn't a quadratic because x was in the denominator. So now you make one side equal to 0. So we're going to subtract 1 from both sides. Because this is not going to work unless we make one side 0. Then you got to pick a method to try factoring. It doesn't take a lot of effort to just try it. If it works, you're done quickly. If it doesn't work, you move on to whatever other method you want to try. So, greatest common factor doesn't have one. Not a perfect square, so it's not one of our special factors. Set up parentheses. What makes the first term? Well, that's either x and 6x, or it's 2x times 3x. What do you want to try? So if I try 2x and 3x, that'll give me 6x squared. Then the signs. Last times last is a negative, so what do my signs have to be? A negative and a positive. Or I always go positive, negative, that just me. I always go plus minus. And here's the good news. Last times last is 1, and the only way to make a 1 is 1 times 1. So it's got to be 1 and a 1. And then you check the middle. Outside times outside is 2x times -1, negative 2x. Inside is positive 3x, and that makes positive x. I don't want positive x, I want negative. So what happens when I have the right quantity but the wrong sign? I switch the signs. So this one should be minus, and that one should be plus. Now I get positive 2x, and I get negative 3x. 2x minus 3x is negative 1x in the middle. So it does factor. Okay. Once it factors, let each factor equal 0. 2x minus 1 equals 0. 3x plus 1 equals 0. Add 1. 2x equals 1 by 2. This x is positive 1/2. Subtract 1. 3x equals negative 1 divided by 3. And this x is negative 1/3. So at the bottom of the box on the test, negative 1/3, comma, positive 1/2. Those are the two answers. Solve it any way you want when you're on a question like this. But if you try factoring, you'll either know quickly or you'll know quickly. You know it will or you know it won't. Or if you just want to go straight to the quadratic formula, then be careful. There's a lot of things you have to keep in mind here. It's got to be equal to 0. A is 6, B is negative 1, C is negative 1. Lots of negatives to keep track of. On number 5, you have to solve by factoring. Solve by factoring. So first of all, it needs to be equal to 0, and it is. Next thing you look for, is it a special, product? Is it one of our special factors? No, because we don't have perfect squares. 48 is not a perfect square. 45 is not a perfect square. So it's not one of our special factors. So then we set up parentheses. And factoring is like putting a puzzle together. You need the pieces of the puzzle in front of you. So the different ways to make a 48x squared. Start with the very first one. X times 48x. That would make 48x squared. 2x and 24x. 3x times 16x. 4x times 12x. 5 does not go into 48. 6x times 8x. 7 doesn't go into 48. The next one would be 8 times 6. We have it already. Make a list of all the pieces of the puzzle, so you have an idea of what pieces you have to work with. Then you got to make a choice. Which of those do you want to start with? Now, here's some advice. The middle is 14. The ends, a 48 and a 45. If you decide to start with an X and a 48 or a 2 and a 24, if you decide to start with any of these larger factors, well, let's say a 12X, okay, either place. 45 is going to be 1 and 45, 3 and 15. Let's just say 5 and 9. If you have a 12 and a 5, that's a 60. 12 times 5 is a 60. Or a 12 times 9. 12 times 9 is a 108. It's going to be hard to get back down to a 14 when you have 108 and you multiply them out. So using these first 4 make really big numbers that you're going to have to try to come back down to a 14. So you might want to start with the 2 numbers that are closest to each other. If the middle is small. Okay. How do you learn how to get there? You have to do a lot of practice. It's not random guessing. That's why I don't call it, guess and check. It's guess and educate, or educated guessing and check. You start to see patterns. So you get better choices. So we're going to try 6x and 8x. One thing you know for sure, the signs have to be what? Positive and a negative. Since the last sign is negative, last times last has to be a negative, they have to be different things. And then Last time glass is 45. Make the list. We can make it 1 and a 45. 3 times 15. 4 doesn't work. 5 times 9. Those are the only way you can make 45. And again, I list them out because I want to make sure I know what all the pieces look like. Now, there's only one way 5 and 9 will fit. I cannot put the 9 with this 6 because the 6 and the 9 have a common factor of 3. 3 goes into 6 2 times, 3 goes into 9 3 times. If I can factor a 3 out of here right now, I should have been able to factor a 3 from the very beginning. So there's no way I can put the 6 and the 9 in the same parentheses. So if it's 5 and 9, the 5 has to be here and the 9 would be here. That's the only way those pieces will fit. It's like I have a piece of, a puzzle piece with sky blue and green grass, and another piece with sky blue and green grass. They're only going to fit with the blue and the green and the green go together. We check the middle. We want negative 14 in the middle. Outside, 6x times negative 9 is negative 54x. Inside is positive 40. Negative 14x. Those puzzle pieces make negative 14 in the middle. The factors. So now, you let each factor equal 0. 6x plus 5 equals 0. 8x minus 9 equals 0. That 5. 6x equals negative 5. 6. Negative 5 over 6. At 9. X equals 9 divided by 8. This is 9 over 8. So, bottom of the box, we have a negative 5 over 6 and a positive 9 over 8. As a mandatory, factoring question you have to do on your test, I would not give you one like a 48x squared. Look at all the choices you have to go through. All of a sudden, you're just doing one question for 45 minutes. I'm not going to give you one that ugly. I gave you one on the review sheet because here's a chance to do something a little more challenging if you will stick with it. It's separate than a test question. Okay. And then number 11 is quadratic formula. You have to use the quadratic form. So you have to put it in standard form first. Now, I made a huge deal last week. And you're going to put it in quadratic formula or quadratic form. Standard form. AX squared plus BX plus C, it has to be equal to 0. The biggest favor you can do yourself, keep the square term positive, or at least make the square term positive. Even if it means moving 2 things instead of just 1 thing. Right now, it's negative 5x squared. We want positive x squared. So you're going to want, and you have to show this step. I want to keep this x squared positive. So that means I'm bringing everything to the left-hand side. So I undo negative 5x squared. I'm adding 5x squared to both sides. I'm going to have to subtract 9x from both sides. So on the left-hand side, I have a positive 5x squared, a negative or minus 9x, and a positive 6 equals 0. do yourself, if rarely, if ever, see anybody get this problem right by moving the 6 over to the right side and using A equals -5. And you got to remember, I take a long time grading this test because I take a microscope to the work. The work has to definitely justify your answer. Parentheses, everything. There's no skipping anything. What you write in step 2 has to justify step 3. So now make a list. A is 5, positive 5. B is -9. C is a 6. Write out the quadratic formula. Give yourself, make sure you know it by heart. X is equal to the opposite of B, plus or minus square root of B squared, minus 4 times A times C. All of that over 2 times A. And then substitute. Don't substitute and simplify, just substitute. Plug in A, B, and C. So X is equal to the opposite. B is -9, so the opposite of the -9. Plus or minus the square root, parentheses, -9 squared, minus 4 times A is a 5, times C is a 6. All over 2 times A, 2 times 5. It X equals +9 plus or minus square root of -9 squared in parentheses of +81. This is minus or negative times a positive times a positive, so it's going to be minus. 4 times 5 is 20. 20 times 6 is 120. All over 10. X is equal to 9 plus or minus the square root of negative what? Negative 39 all over 10. And then you got to simplify as far as you can go. Can't leave a negative inside the radical. So you poke out the I. 9 plus or minus, we poke out the I. Square root of 39 is just 3 times 13. Nothing's breaking out of that. So this is just plus or minus I square root 39 all over 10. And you can leave it like this, or you can split it up into 9 over 10 plus or minus I square root 39 all over 10. Please put the I in front of the square root, not behind it. There's a few of you that put it behind it, and it looks like it's underneath the square root. Made a big deal about that, too. Any clarification on either one of these three?
I don't know very much, but if I was saying I'm going to remember that day.
Wait, what?
For 5, you said you were going to give the X squared, right, to make it up as big as 48.
Right, I wouldn't give you something as ugly with that many factors that you would have to go through as your mandatory test question. Maybe bonus, but not mandatory. Yeah, bonus is with it. Bonus is right there with it. So the test is only 14 questions and then 6 bonus. So you have the whole class period, or as soon as I can check the homework or collect the homework. So if you're prepped and ready to go from the review sheet, you should be ready to go here. And it's very straightforward. It's one of each kind from 14 through 20. One just like each one of those. So one factoring, one complete the square, one quadratic formula, and then one from each kind of 14 through 20. So what's next? And then basically one like numbers 1, 2, 3, and 4.
Seven.
Was it 6? Seven. Okay, factoring. Now, 7 is a nice factoring question because the numbers can get smaller. But it takes a little remembering about step 1. Seven is 16x squared. Equals 24x plus 112. Okay, first of all, it doesn't do us any good to do anything unless it equals 0 first. So again, don't ever say these words or this one word. Don't ever say a phrase where it says, it looks easier. Or isn't it easier? You know what? Easy is usually the path to not. It is the path of destruction. It really is. Be challenged. And you challenge yourself, you grow. There must be a reason why I gave it and wrote it up like this. Moving this to the right side means you have to subtract 16x squared. So you have negative 16x squared. It's not going to work out nice if you want to factor a negative 16x squared. So you're better off bringing these two to the left. Minus 24x minus 112. So this is 16x squared minus 24x minus 112 equals 0. Now, factoring. First step, take out the greatest common factor. Well, 16, 24, and 12. They have what in common? 16 and 24. The biggest number they have in common is 8. They have an 8 in common. Now, is 112 divisible by 8? You can just check on your calculator, and yes, it is. 8 goes into 112 as well. So that means each one of those is divisible by 8. I can factor an 8 out, which makes the numbers smaller to work with, which means there's fewer possible factorings I have to go through. Divide by 8, divide by 8, divide by 8. So this is 2x squared minus 3x. This is going to be minus 14. When it was 16x squared, you had x and 16x. You had 2x and 8x. You had 4x and 4x that you would have to go through. But now you just have a 2x squared. And the only way you're going to make a 2x squared is an x and a 2x. You only have one thing to check, x and 2x. Because you took out the greatest common factor. Okay. The last sign is negative. So our signs have to be a positive and a negative. Again, maybe we have to switch them. And then last times last is 14. So it's either 1 and 14 or it's 2 and 7. So what do you think you want to try? 2 and 7. And if you think about the possible arrangements, I cannot put a 2 with a 2. If I put a 2 in here, then I have a factor of 2 that I should have been able to take out here. So the only way 2 and 7 are going to fit would be 2 here, 7 there. Check the middle. Outside times outside is negative 7x. Inside times inside, 2 times 2x is positive 4x. Negative 3x in the middle. But it's a lot nicer to get there if you take out the 8 first. Now, if you only took out a 2, you have more choices, but you still have to make an 8x for it. If you took out a 4, you'd still have bigger numbers to try to crunch. When you take out the greatest common factor, you have the fewest numbers you have to crunch. So now, we're only solving for x. If our factor has an x, you let that factor equal 0. 8 does not have an x. So the only factors that have x's, this one, could be the 0 or the 2x minus 7 equals 0. We don't let the 8 equal 0 because 8 can't be 0. We're not solving that part. Subtract 2. This x would be negative. We would have to add 7. 2x equals 7. Divide by 2. And this is 7 over 2. So x is negative 2 and a 7 over 2. Right. Yeah. And then number 10, solve by completing the square. Number 10 is a really good example of bonus complete the square question. Okay. Step 1, isolate the constant. So we subtract 8 from both sides. Leave an empty spot where the 8 was. So we have 5x squared plus 12x, leave an empty spot, equals negative 8. Step 2, complete the square. We got to make sure it's 1 times x squared. We have to check the a, make sure this is a equals a 1. It's not, it's a 5. If a doesn't equal 1, you divide all the terms by whatever this is. But everybody's going to get divided by a 5. So now we have 1x squared plus 12 over 5 times x equals negative 8 over 5. That's step 2. Step 3. Remember what I told you. We write this down over here on the side. We take half of b. So half of b is 12 fifths. B is the coefficient of x to the first. So half of 12 over 5. Now, half of 12 over 5 is 6 over 5. Okay? Reduce it. This is 2 goes into 2 once, 2 goes into 12 6 times, so I get 6 over 5. If you can reduce it, obviously we always like smaller numbers. Then you square it. So 6 squared, 36. 5 squared, 25. Half of b, 6/5, square it, 36 over 25. Add that to both sides. Now, when you add these together, you're adding fractions. You have negative 8 over 5 plus 36 over 25. So the common denominator is going to be 25. For 5 and 25, it's going to be 25. First thing, this one is a negative. To make a 5 into a 25, you have to multiply this fraction by 5 over 5. So the numerator is negative 40 over 25 plus 36 over 25. Negative 40 plus 36, this is negative 4 over 25. Any questions there? You have to keep it in fractions, no decimals. We just made a perfect square. Right here, this is a nice perfect square. And it's either a plus b perfect square or an a minus b perfect square. Now we know it's going to be a plus because these are both pluses. Since that's x squared, it's going to be x. X times x or x squared. It's going to be a plus. And then that's a fraction. So last times last has to be a fraction. The numerator is 36. What times itself is 36? 6 times 6 is going to be 36 in the numerator. The denominator is 25. Down below, what times itself is 25? 5 times 5. 6/5 goes here. Now, last week I told you the reason why I put that stuff on the side. Half of b. Before I square it, I have my half of b in the parentheses. Positive 6 over 5 is exactly what ends up right there every single time if I write it out correctly. But that's why I write out specifically, as it's written, 1/2 of the b. And then I get 6/5. That's what's going to go right there. And then that's before I square it. That's what I have to do. So then it becomes the square root method. Parentheses, x plus 6/5 perfect square equals negative 4 over 25. Take the square root of both sides. Don't forget your plus and minus and simplify. So this is x plus 6 over 5 equals, we have plus or minus. Square root of the negative, we're going to poke out the I. This is square root 4 over square root 25. So that's 2 over 5. So 2i over 5. And then we subtract 6 over 5 on both sides. Can you combine the 6/5 with a 2i? A real with an imaginary. You add them together, subtract them. No, so it's negative 6/5 plus or minus 2I all over 5. Leave it like that. No, because that means I is in the denominator. So if you go negative 6/5 plus or minus 2, and then it looks like the 5 and the I down here, you can't have I in the denominator. That's what it looks like. You'd have to rationalize. If you wrote it like this, where it looks like it's 2/5 times the I, that's okay. Because now it doesn't look like it's in the denominator. But to be safe, if you leave it in the numerator, now there's no chance of confusion. Okay. Yeah. Okay. On number 4, you can't have an I in the denominator. We have to rationalize the denominator because it has 2 terms. This was your quiz question, bonus on the quiz. You multiply by the conjugate. The conjugate is exactly these 2 terms, but you change this sign. So instead of a minus, the conjugate's going to be 4 plus 8i. And whatever you do to the denominator, you have to do the same thing to the numerator. Because you're multiplying by a 1. Now, the numerator is 2 terms, so it needs parentheses because we're going to distribute. Going to FOIL it out. The numerator, take it slow. 3 times 4, that's a 12. Positive 3 times 8i, that's a positive 24i. Positive 2i times 4, that's a positive 8i. 2i times 8i, that's a positive 16i squared. And that's what I was missing, or that's what some of you were missing when you were multiplying that out, is you weren't putting I squared. Okay? 2i times 8i, 2 times 8 is 16, and then I times I gives you I squared. Over. If you recognize the difference of 2 perfect squares, you can go straight to this will be 16 minus 64i squared if you want to. That's what this is going to equal. But if you don't want to take that chance, distribute 4 times 4, 16. 4 times 8i is positive 32i. Negative 8i times 4 is negative 32i. A negative times a positive is a negative. 8i times 8i, 64i squared. Because these 2 combine and make a 0, that's why I have 16 and a minus 64i squared. So then we simplify. There are 12, that one. 24i plus 8i, that's 32i. And then this. This is positive 16. I squared is a negative 1, so it ends up being minus 16. One thing I did notice is, and it was just maybe less than a handful, took the I squared, made it a negative 1, and then still had an I there. The I squared becomes negative 1. There's no I left over, just negative 1. Down below, we have that 16. These 2 cancel out, make it 0. This is negative 64. I squared is negative 1, so it ends up being positive 64 plus 64. We can combine the 12 and the negative 16. So that's negative 4 plus 32i all over 8. Okay. I harped on this last week a bunch of times. You have to simplify completely. And you have to show the work. So you either have to show something here, you either have to show that you factor it or you do the splits. You cannot just cross things off. You can't just show me the answer. You have to show the how you get it. You can't just go. I can't do it in my head. You can't just go to that. I go, well, how'd you get that? There's no work. So either you show that you factor, then you reduce. 4, 32, and 8 are all, well, the only thing you could possibly factor out is a 4. So I factor out a 4. So that's 4 times. If I divide by 4, that gives me -1. Divide by 4, I get a plus 8i. All over, this is 4 times 20. The 4's reduced. Now I have -1 plus 8i all over 20. They don't have anything left in common. We're done. You want to play it safe? Do the splits. This is, split it up. This is 4 over 80. And then plus 32 over 80 or 32i over 80. So this is negative 4 times 1 over 4 times 20 plus 16 times 2i over 16 times 5. So here, the 4's reduced, and you get -1 over 20. The 4's reduced, I get -1/20 plus the 16's reduced, and I get 2i over 5. They're the same answer. They're on the negative, so they're not the same. Now they are. But I showed the work. I either show the split and reduce each individual fraction, or I have to factor the 4 out before I can reduce. You can't just start crossing things off. You can't cross things off because it's not factoring. You can only reduce common factors, not additions or subtractions. The work has to be there. Like I say, split it up and reduce individual fractions. Like that was less. Square root of 18 plus 2 square root of -8 minus 3 square root of 2 plus square root of -50. It's multiplication. But the order of operation says parentheses should happen first. And if we have exponents, then multiply and or divide in order from left to right, then add and or subtract. Parentheses. Simplify what you try to do. This is 9 times 2. 3 times 3 times 2. Simplify the square root of 18. A 3 breaks out with a 2 back in square root j. Plus, this is 2. 2 is the getaway car. Poke out an I. 8 is 2 times 2 times 2. So a 2 escapes with a 2 back in square root j. So this first parenthesis is 3 square root 2 plus 4i square root 2. Can I combine those two together? No, because one is imaginary, one is real. Times 3 square root 2, that doesn't simplify. Plus, poke out the I. Square root 50. 25 times 2. 5 times 5 times 2. So a 5 breaks out. 5i and a 2 left behind. So this is 3 square root 2 plus 5i square root 2. You can't combine those either because they're not like terms. One's real, one's imaginary. So now multiply them out, FOIL. And when you have something that ugly, you may want to write out each multiplication problem. This 3 square root 2 times that 3 square root 2. So 3 square root 2 times 3 square root 2. Maybe you don't need to, but maybe you should. Positive times a positive, it's going to be a positive. It's 3 square root 2 times 5i square root 2. Then positive times a positive, that's positive. 4i square root 2 times 3 square root 2. And then last times last, positive times a positive, that's a positive. 4i square root 2 times 5i square root 2. I just wrote them out. I didn't multiply them all. Here's what's going to happen. This right here, here's what I hope you'll be able to do. This is 9 times 2. Because it's 3 times square root 2 times 3 times square root 2. And according to the commutative property, you can switch this order. And what you end up with is 3 times 3 times square root 2 times square root 2. 3 times 3, that gives me the 9. Square root 2 times square root 2 is, whether you want to look at it, square root 2 times square root 2 as the square root of 4, which is just 2, or square root 2 times square root 2 is the square root of 2 squared, which is just 2. If you multiply square root times itself, you get the inside because you're squaring it. And that gives me 18 right here. Then plus, this is 3 times square root 2 times 5i times square root 2. Remember how we can manipulate this. We can change the order, 3 times 5. And then we have a square root 2 times a square root 2, and then the I would be left. Because that's a 15. Square root 2 times square root 2 is just a 2, and then we have an I. So that's a 30 I. But I hope you see, hey, 3 times 5, that's 15. Square root 2 times square root 2 is 2. So you go from here to here. 3 times 3 is 9. Square root 2 times square root 2 is 2. 9 times 2. Let's try it. 4 times 3 is what? 12. Square root 2 times square root 2 is 2. And then we have a 9. 24. 9. And then here, we have 4 times 5, that's a 20. We have I times I, that's an I squared. And square root 2 times square root 2 is a 2. 20 times 2 is 40. What's I squared? Negative 1. So positive 40 times negative 1 is a minus 40. My two like terms, 18 and negative 40 is negative 22. 30 plus 30i plus 24i is positive 54i. I made this one on the review sheet much more challenging than the test one. Somewhere between the quiz, because you had one like this on the quiz, but these are all nice, perfect squares. Okay, somewhere between the quiz and the review sheet. Next.
Number 23.
Okay, 20. Don't forget, anybody and everybody's welcome to be in the co-rec at 8:30, office hours tomorrow at 12. Wednesday at 7:30, co-rec at 8:30, test is at 10. A plus. Where we do x minus 3. Equals 13. Number 14. So when you're solving a radical equation, as we did on Wednesday last week, you isolate the radical. So I want that square root by itself. We're going to subtract 8 from both sides. So square root 2x minus 3. 13 minus 8 is 5. Isolate the radical. Then you undo the radical. Since it's a square root, we're going to square both sides. On the bonus, that's a cube root. So you raise both sides to the third power. Square root, we square both sides. Now, because we're squaring, not taking the square root, it's not plus or minus. It's 2x minus 3. I to the second is just 25, not plus or minus 25, just 25. 5 times 5, 25. And then we solve. Add 3. 2x equals 28. Divided by 2. We get x equals 14. Now, one thing you have to be careful about, solving square roots, solving radical equations, you have to check your answer in the original question. What we just solved was something that did not have a radical. We know that square roots have, kind of funky domains. Can't take square roots of negatives, things like that. So just 2 times 14 is what?
28.
28. 28 minus 3. What's square root of 25? What's 8 plus 5? Well, works. So x equals 14. Just, you don't have to show the work, just make sure you check it before you write it down. If it doesn't work, it doesn't have a solution. Or maybe you made a mistake along the way. Recheck.
I'm sorry, why did you say this is not plus or minus?
Because I'm squaring it, I'm not taking the square root of both sides. 5 to the second is just 5 times 5, which is positive 25. When you do the square root method, then we're completing the square or quadratic. Then there's the built-in plus or minus. Okay. So it any way you want. It's not even a quadratic technically yet, so you're going to have to multiply it out. Make one side 0, combine like terms. So a little bit more room. And that is, one thing. Each question basically comes like in a quarter of the page, so you do have a lot of room, at least in my opinion. But some of you write like you're on the whiteboard. Might want to clean it up or a good eraser. 2x plus 5 squared minus 3 times 2x plus 5 minus 20. So this, when you multiply it out, is going to be 4x squared plus 20x plus 25. And then distribute the negative 3. Minus 6x minus 15 minus 28 equals 0. On this type of a question, that's where the biggest mistakes happen, is just on putting it in quadratic form. Remembering that this is 2x plus 5 times 2x plus 5. 4x squared plus 10x plus another 10x and then the plus 25. Simplify. 4x squared 20x minus 6x is 14x. 25 minus 15 is 10. 10 minus 28 is negative 18. So now it's in quadratic form. Pick a method for solving. I shall pick trifactoring. Is there a greatest common factor to think about first? The biggest clue would be the fact that they're all even. So factor out A. 2. That's 2 times. Divide 2 out of there. 2 times 2x squared plus 7x minus 9. 2 times parentheses. So now the first term is 2x squared. So that's going to have to be x and 2x. The last sign is negative, so my signs have to be opposite. One's positive, one's negative. And then the factors for 9. The factors of 9 are either 1 and 9 or 3 and 3. And then make a choice, 1 and 9 or 3 and 3. We try 3, 3. That's negative 3x. That's positive 6. That's going to give me positive 3, not 7. Switching the 3s obviously doesn't do any good, and switching the signs is going to give me a negative 3. So it's not 3, 3. It has to be 1, 9. So if I randomly do it, so hey, 1, 9. That's negative 9x. That's positive 2x. That's negative 7. I want positive. So that's what the signs are. We'll make this the negative, that's the positive, positive 9x minus 2x. Okay. So x minus 1, 2x plus 9. Add 1, x equals 1, subtract 9. 2x equals negative 9 by 2, negative 9 over 2. But if you do not get to 4x squared plus 14x minus 8 from here to here, it doesn't work. Again, the work has to be plus 14 plus bonus 6. Another radical equation, you have to isolate the radical first. So the first thing you should do is subtract 5 from both sides. And that gives us 4 times the cube root of 2x minus 1 equals 25 minus 5, that's a 20. And then divide both sides by 4. And so that's the cube root of 2x minus 1 equals 5. Isolate the radical. So we just have the radical on one side. Now we're going to undo the radical. To undo a cube root, you raise both sides to the 3rd power. So the cube root of 2x minus 1 to the 3rd is just the 2x minus 1. 5 to the 3rd is the 125. Then we solve it. Add 1. So we get 2x equals 126. Divided by 2. X is equal to 63. Plug it in and check. 5 plus 4 times cube root 2 times 63 minus 1 is supposed to be 25. So 2 times 63 is 126. 126 minus 1, that's 4 times the cube root of 125. The cube root of 125 is 5. So that's 5 plus 4 times 5. 4 times 5 is 20. 5 plus 20. 25 equals 25. What's next?
Number 15.
Number 15, then what? 15, then 19. Promise you'll have one line number 50. I promise you'll be able to do number 15 the way I'm about to show you. I promise that if you use the quadratic formula, you will get 0 points because you can't. Every semester. Why can't you use the quadratic formula on number 15? Because it's x to the 4. It's not a quadratic. Quadratic is ax squared, not an x to the 4. So what am I going to say? Try factoring. No common factors. Set up the parentheses. First times first is x to the 4th, so that has to be x squared times x squared. The only way we're going to get our x to the 4th is x squared times x squared. That makes it x to the 4th. Then you do the signs. Last times last is a negative. So the signs would have to be a positive times a negative to make a negative. Then last times last is a 9, so it's either 1 and 9 or 3 and 3. Which of those have the best chance of making an 8 in the middle? 1 and 9. Since we want positive 8, who should be positive? The 1 or the 9? 9 should be the positive and the 1 should be the negative. Double check it. Outside is negative x squared. Inside is positive 9x squared. And that adds up to positive 8x squared. And that's what we wanted. So we factored it. Once it's factored, then each factor equals 0. And your two factors are just square root method. You have a perfect square and a number. So now you just subtract 9. X squared equals negative 9. Take the square root. Don't forget your plus and minus. Square root of a negative, poke out the I. Square root of 9 is 3. So plus or minus 3i. Add 1. X squared is equal to positive 1. Take the square root. Don't forget your plus and minus. Square root of 1 is 1. So x equals a plus or minus 3i, comma, a plus or minus a 1. Every semester, people putting that in the quadratic formula. It's not a quadratic. Likewise, number 19 is not a quadratic either. And more importantly, it's got fractions. So the least common denominator. I need to undo x minus 2. So my least common denominator has to have an x minus 2 in it. I have to also undo an x minus 1. So I have to have an x minus 1 in it. Those are the two denominators that must be undone. That's what I have to multiply every term by. That's the least common denominator. So everybody's going to get multiplied by x minus 2 times x minus 1. Now, here's what is driving me crazy. This is what I'm seeing. What I saw in the quiz. Right here. It's like way down here. And try to keep track of what you're going to have left over in the numerator to multiply by. And just like one thing on the outside, and then trying to remember what's getting distributed to each one. It's minimizing the amount of work, doing it what you might feel is the easy way, doesn't help. I will try to give you a little bit more space in between to work with, but you really should, like I've been doing every single time, writing it right next to the fraction every single time. So you can see what you have left over. Here, the x minus 2 is going to reduce. I'm actually going to write this down before I distribute. I have an x times an x minus 1 left over. Plus, the x minus 1 reduces. I have a 2x times an x minus 2 left over. Equals. This is 6 times. I'm going to go ahead and distribute this. Here's my advice. If I distribute 6 right now, I end up with 6x minus 12, and then times this one. It's a lot nicer to distribute a single term, the 6, last. Take a look. 6 times x squared minus x minus 2x plus 2. 6 times x squared minus 3x plus 2. It's going to be a lot nicer to multiply this out by just distributing 6 than it would have been to go 6x minus 12 and FOIL it with x minus 1. So whenever I have that constant, and just leave that out in front, I'll multiply it last. This is x squared minus x. This is 2x times x, so 2x squared, minus 4x. This is 6x squared, minus 18x, plus 12. Then I see impatience take over. Start trying to move things left and right. We're not done simplifying. X squared plus 2x squared, that's 3x squared. Minus x minus 4x, that's negative 5x. And I actually forgot to do one really important step. Probably the most important step to be careful with from the very beginning. And this is something that is I always forget to do when I'm teaching. Because I know you guys can be impatient, so I better get to the problem. You have to be aware of potential extraneous solution. If I get X equal to what?
2.
2. 2 minus 2 in this denominator would be 0. Can't have 0 then. Or X equals what? 1. If I get X equal to a 2 or a 1, I have to throw them away because they won't work in the original problem. The original problem has X in the denominator. The one I'm solving right now has no denominator. Maybe a 2 or a 1 will work here, but I can't use it in the original. So you have to be aware of it. So now, we're at 3x squared minus 5x equals 6x squared minus 18x plus 12. Are we taking x squareds to the left or to the right? To the right. Because if I subtract 6x squared, I'm going to have negative x squared. Subtract 3x squared from the times. Add 5x. And there we have 0 equals 3x squared. This is minus 13x plus 12. I'm going to check factoring. If it factors, it would have to be x and 3x for 3x squared. My signs have to both be negative. So if it factors, x and 3x for 3x squared, since that's positive and this is negative, it can both be negative. The only way to make it 12 would be 1 and 12, 2 and 6, or 3 and 4. So what do you want to try? Pick one. 1 and 12. If I go 1 to 12, I can't put 12 to 3 because there's a common factor of 3. So if it fits, it would have to be 12 here, 1 there, and that's negative 36 plus, and that's not going to make 13. So it's not 1 and 12. So if I try 2 and 6, I can't put 6 with 3. So it would have to be 6 here and 2 there, negative 18, and then minus 2 is negative 20. Nope. If I tried 3 and 4, it would have to be 3 here, 4 there. That is negative 4x. That is negative 9x. That is negative 13x in the middle. So back. Huh. We keep saying try back, and I don't believe it. I'm going to keep doing it like, plugging huge numbers, try to come. We're not saying they all are going to factor. There might be one, but checking the factoring doesn't take a lot of work. X minus 3 equals 0. X minus 4 equals 0. I do know that when people say I didn't have enough time, well, if you tried factoring, if you tried factoring, you probably would have been done in half the time. So we didn't get a 1 or a 2, we got a 3 and a 4/3, so it's a the end. We got time for one more. Please make sure you use 16 the way I kept carpet it out last week. Number 6. Number 6, the directions say, solve by factor. 3x to the third. Equals negative 48x. Well, first thing about factoring, it has to be equal to 0. So we have to add 48x to both sides. You want to talk slower? So 3x to the third plus 48x equals 0. Now the first step for factoring, take out the greatest common factor. 3 and 48, you can take out a 3. And then x to the third and x to the first. They each have an x to the first in common. So you can factor a 3x out of each one. Divide by 3x. So 3x to the third, divided by 3x, you're just left with x squared. Plus 38x divided by 3x is 16. Now, solve by factor. We just factored out the greatest common factor. If you've watched the video on, factoring that we did in the co-rec, one of the things we found out is, listen to special factors, the a squared minus b squared, that's our best friend, because that's just a plus b times a minus b. But then we listed that a squared plus b squared. The sum of two perfect squares is prime. It will not factor. X squared plus 16 is done. It's not going to factor. But it's the square root method. Solved by factoring, we factored out 3x. So this one equals 0. X squared plus 16 equals 0. Here we divide by 3. So this x is 0. Subtract 16. X squared is equal to negative 16. Take the square root. X equals, don't forget the plus and minus. Poke out the I. Square root of 16 is 4. So we get x is equal to 0, comma, and then a plus or minus of 4i. To have your homework ready, stapled, everything ready to go, filled out, ready to turn in. And that will be on Wednesday. Remember, office hours tomorrow morning, 7:30, to tomorrow at noon. Wednesday morning, welcome to the co-rec. Make sure you notice that the change on homework 2.5.